Alright, welcome back to part 2 of this video, talking about sprockets, gearing for your mini bike, go-kart, etc. One thing I'd like to correct on my last video, I kept saying gears when I actually was talking about sprockets. These are sprockets, not gears. Gears intermesh with each other. So let me correct myself on that. Kind of got into a lot of technical stuff on the last video. This one I'm just going to kind of go over a review a little bit of what we talked about, and the complicated part of this video I'm going to show all the equations if you want to calculate your speed or your final end torque of this system. Anyway, back to reviewing. So gear ratio is your output gear divided by your input gear. Okay, and this is your tooth. In sprockets you can use tooth count. So count how many teeth you got on the output gear. Like say here, 50 divided by input gear is 10. You get a gear ratio 5-to-1, or you can just say 5. So also gear ratio is of the whole system. If you got two systems here, just like I said, on the factory Coleman setup with the jack shaft, you got a 10-to-20, and that same shaft does a 10-to-50. You take the gear ratios of these two, so this one's 2-to-1, this one's 5-to-1, so you multiply 2 times 5, your overall is a 10-to-1 or a 10 gear ratio. If you want to increase torque on your setup and this decreases speed, you need to increase your gear ratio. So what you need to do is increase the amount of teeth on your output gear. You can make this gear bigger, so you can go up to a 72 tooth, or you can take this sprocket and go down in teeth, so down in the input gear. So you can actually make you can change this to an 8 tooth, and it'd actually be more torque than if you put a 60 tooth sprocket in the rear when you calculate it out, because it's like so you get 50 divided by 8, 6 times 8, 6.25 would be your gear ratio there, whereas 60 here and a 10 would be 6. So you actually get more torque if you just put an 8 tooth here. It's actually cheaper than buying a 62 sprocket. If you want to decrease torque, if you just want more speed, decrease your gear ratio. Change your output gear. Put less teeth, a sprocket with less teeth on the output, or you can increase the input amount of teeth here. If you wanted more speed in this situation, you could take this one down to a 38 tooth sprocket, or you can bump this one up to a 12 tooth sprocket or 20 tooth sprocket. A lot of guys, what they do is they get rid of the whole jack shaft and they connect this straight to here to get more speed. And so again, the overall ratio, the stock Coleman's 10-to-1. They're essentially doing a 10-to-50 straight off the clutch by putting the clutch and flipping it backwards, so it's lined up properly. And they're getting a 5-to-1 gear ratio. So they have essentially doubled their speed of their factory setup. The problem is it may not have enough power depending on how much you weigh. So torque. If you take your input torque, or whatever your engine output is, and multiply it by the gear ratio, that gives you the torque at the output gear. So the Coleman 6.5 horsepower factory engine and Predators, I'm going to say 7.5 foot-pounds of torque. So if you got 7.5 foot-pounds of torque, I'm not going to write that, that was a crap. Anyway, 7.5 multiplied by 10, you essentially have 75 foot-pounds of torque at the rear wheels. Okay? And the speed is you take your input RPM and you divide by the gear ratio. Or you can multiply the input RPM by the inverse of the gear ratio, so you're flipping this fraction. So you can multiply RPM times input over output. Okay? So in this situation, 10-to-1 on a factory Coleman, if you remove the throttle screw and you get approximately, the governor starts, it biases the governor up to 4,600 RPMs. So we're going to take input RPM, 4,600 RPMs divided by gear ratio of 10. That means that at top speed, when the governor kicks in, your axle is spinning at 460 RPMs. Okay, and this is how you calculate speed, because then you could just take your tire diameter and figure out actually what your miles per hour is, and that's what I'm going to talk about next. And I'm going to draw out the equations of starting input RPMs to show you how you can change the values around and, you know, tweak the numbers to get the correct speed, correct amount of torque, etc. But I'm mostly going to deal with speed, and we'll go from there. All right, what I got here is the basic equations for if you have a jack shaft set up on a go-kart mini bike. What I've labeled here is assuming the clutch here is what we're going to call it G1. The jack shaft that clutch connects to, this is going to be G2. G3 is going to be the 10 tooth here. G4 is going to be your final axle sprocket. Alright, so you want to calculate speed. So what this equation's doing step by step is, so input rotations over per minute, that's the same as RPM of the engine. And first thing we're going to do is we're going to multiply by, or essentially this is the same as dividing by the gear ratio, but we're multiplying by the inverse of the gear ratio, G1 over G2. And so this section right here gives you the RPMs of the jack shaft. Okay, and then when we multiply by the inverse gear ratio of the second section, you are getting now the RPMs at the axle. So we know that this up to here is RPMs, and so we know to cancel out the minutes and change it in an hour, you put 60 minutes per hour. That cancels minutes. And then to cancel rotations and turn it into inches, one rotation is equal to pi d, which is the circumference of your tire. D is the diameter of the tire. So we got inches here. To cancel inches, turn them into feet. We do times 1 foot over 12 inches. So now we have feet per hour. And to change it to miles per hour, we multiply by 1 mile is equal to 5,280. And so to show you that this works, all right, so factory Coleman, 4,600 RPMs is what a fully backed out screw Coleman usually does. So multiply that by G1, which is 10, times G3. We're just going to multiply everything up top here and then divide at the bottom, times G3, which is 10, times 60, times pi, which is 3.14, times the diameter of these tires factory about 18.5, and that's it for the top. So we get this big massive number up top, and then we start divide by G2, which is 20, and then divide by G4, which is 50, divide by 12 for the inches part, and then we'll divide by 5,280, and that gives you 25 miles an hour, 25.3 miles per hour is the top speed of the factory setup, just screw backed out. This has been confirmed multiple times. I confirmed this GPS, this is correct. So the next thing to do, so we know this is the equation here. That's complicated. I know I don't want to go through this the whole time, so I've simplified this out to speed with jack shaft, and we got gear 1 times gear 2 times pi times diameter of the tire times RPM of the engine times 60, and that is actually, I can take RPM pi G1 G3. I'm sorry, that was G3. We can take that 60 out and simplify it even more. G2 times G4 times 10. Oh, Jesus, man, my writing's awful. 1056. All right. Somewhere right down that equation, if you ever want to figure out the speed of your engine with the jack shaft, that's the equation you need. And let's just double check this. You got 10 times 10, 10 times 10 times 3.14 times diameter 18.5 times 4,600 RPMs, divide by G2, which is 20, divide by G4, which is 50, and then divide by 1056. Same number we got before. Okay, so that's the properly simplified way down. Now, if you have a torque converter and you want to calculate this, it's pretty much the same equation. The only thing is you're going to take the gear ratio of the torque converter. It has an infinite ratio. It starts out at a 2.68 to 1. Let me write that down. Torque converter GR1 equals 2.68 to 1. Torque converter GR2 equals 0.09? Yeah, 0.9. Okay. So what that means is torque converter, when it starts out, it's in has a high gear ratio, so it gives you more torque. And then as you're driving along and the torque converter starts shifting, it'll actually go into an overdrive of 0.9. Okay. So the 2.68 is equal to G2 over G1 if you were translating it to your jack shaft situation. Okay, so it says 2.68 is G2 over G1. Then you can substitute this into this original equation, and let me straighten this up a little bit and draw it a little better. All right, going back to calculating top speed of a torque converter. Again, these gear ratios represent essentially G2 over G1 of the equation we set up here. The one you need to be looking at is the final gear ratio of the torque converter, because this is where your top speed lockup's at. So if G2 over G1 is 0.9, you notice here G1 is over G2 here. So what that means is you need to divide by this number. So what I've done is translated the equation G3, which is your jack shaft or your gear on the end of on the back side of the torque converter driven unit, is G3, and your axle gear is G4 sprocket. Sorry, geez, man, I keep forgetting to say that. So G3 times pi times diameter of your tires times RPM for about 4,600 divided by G4 axle sprocket 10 times 1056 times your torque converter top gear ratio, which is 0.9. So let's go through this one. So G3 is 10 times, well, I'm sorry, let me move over here so you can see it, times pi 3.14 times diameter is 18.5 times RPM 4,600. Got that. Divided by G4, which is 50 on the stock Coleman, divided by 1056, then divided by 0.9. So that is your theoretical top speed on a torque converter. The only problem is everybody's got a lot of weight in their belly, and it is extremely hard to hit 56. You're running into rolling resistance, friction, weight, and everything. Most guys are only getting 42 miles an hour, and so that's why I actually gear mine a little bit lower. My rule of thumb is if you're not hitting the governor and you're topping out, you need to gear it lower, because if you can only get up to 42, might as well gear your vehicle lower so you can get up to 42 faster. Okay. Now, if you have a clutch to, if you have a clutch that goes from G1 to G4, you know, just boom, you got that. So speed, just clutch. It's essentially the same as this, except I'm just changing G3 to, we're making this G1 times pi times D times RPM. And then we're going to do G4 here. So it's going to be this gear, or that sprocket, that one. And then 1056 stays the same. And my God, my handwriting's awful. And then just ignore the torque converter one. So your equations for calculating speed now. We got the jack shaft set up, G1 times G3 times pi times D times RPM, G2 times G4 times 1056. If you got a torque converter, again taking the 0.9 highest, the shifting gear ratio, G3 pi D RPM G4 1056 times that 0.9 of a torque converter 30 series with a 6-inch driven pulley, which is pretty much the one everybody has. And if you got just clutch, it's G1 sprocket count times pi times D times RPM divided by G4 times 1056. If you so this is for the 6-inch driven. If you got a 7-inch driven, like a Yerf dog, these numbers, the 268 now becomes 3.13, and your top gear ratio is 1.12. So if you get a 7-inch driven pulley, you actually get more torque, but you lose a little bit of top speed. So that's one thing to consider. Now let me talk about this app. Well, it's not an app, but it's a web page you have to type it in on your phone. It doesn't work with a PC browser. It'll actually say get on your phone to check it out. But anyway, it's, if you can see that, it's, hold on, wait, sure you can. Can you see that? Okay, app.cartcalc.net/#justcalc. All right, so here you type in 18.5. Well, actually, let me back up. All right, so you can go to that main web page /home, and I usually do quick count. Okay, so the top one is, let me refresh that. I'll tell you what, hold on, let me just close all out. One second, bear with me here. I just wanted to show what the default screen looks like. Okay, there we go. All right, so we have rear wheel diameter focus. There you go. This is going to be 18.5. Weight of cart plus driver. For some reason, they want you to input this in kilograms. We'll just say 150, and that includes you and the bike. Engine horsepower, the stock Coleman is about 6.5. Max RPM 4,600. Now the factory one's going to be clutch and jack shaft. Tooth count clutch sprocket. We know that's a 10. Jack shaft in is 20. Tooth count jack shaft out is 10, and axle sprocket is 50. Okay, so now we got them all. Let me zoom out. We go here. For some reason it gives it in kilometers per hour, so come up here to hit that button to change it to kilometers per hour, and you see 25.32. Come on, focus. There you go. If you have a torque converter, just switch this to torque converter CVT, okay? And 10 is 10.2, so what usually comes with it, and you're keeping your 50. And it says series 30 in 6D. That's how many, the number before the D is how many inches your driven is. Majority of them are 6. Like I said, if you got a ear fog, that'd be 7. So it's not 90. There you go. Come on, focus. There you go. 56.26 miles per hour. But this is where the weight comes in. This guy, I don't know how they figured this, but they're saying theoretical is 54.97. It's actually less than that. You'd have to be almost like 50 pounds to hit that on one of these mini bikes. But hopefully, if you're looking for some technical information on this stuff, hopefully this video helped you. If you like this video, give it a thumbs up. I'm going to be explaining more about torque converters, more technical stuff. If you'd like to see that, please subscribe to my channel. And thanks for watching.